Chapter 13. Einstein's Theories Examined. Whatever it is that relativity is supposed to establish is to be disproved backwards, beginning with the example which Einstein puts forward, where an observer standing at the center of a rotating disk is watching someone else on the same disk measuring the circumference of a circle round the observer by repeated applications of a small measuring rod, and afterwards measuring the diameter of the circle in the same way. Diagram 27. He says that because the disk is in motion, the small measuring rod will appear to the observer at the center to be contracted, so that the person who is measuring, whom I will call B, will have to apply the rod more often to go round that circle than he would if the disk was at rest. That is not true. If B actually lays the rod or foot rule down upon the disk correctly, the number of applications to go round the circle will be the same whether the disk is moving or not. And the observer at the center will see that it is so, if he is not made too dizzy to count. On the other hand, if B does not lay the rod down and measure the circle as one would expect, but only walks round the disk with the rod in the air, as in diagram 27, then the rotation of the disk will disturb him, so that he has to make an effort to preserve his balance, with the result that he cannot place the rod as accurately as he would if the disk were not in motion. And in that case, it may take either more or less applications of the rule to go completely round than it would if the disk were still. And that difference would be seen by the observer at the center, not as an optical illusion, as Einstein implies, but in reality as a result that is entirely physical and due to physical causes. When walking across the disk and measuring the diameter, B is not disturbed to anything like the same degree as in walking round the circumference, and so he measures the diameter more accurately. Most of us have at some time or another witnessed the antics of a clown trying to run or walk upon a spinning disk in a circus, and this enables us to understand how such motion would affect our friends performing on Einstein's revolving table. His example is merely amusing. It serves no useful purpose and proves nothing, unless indeed it proves by analogy that the inhabitants on a spinning earth would be rendered as incapable of acting and judging things correctly as his examples. What we have always known as a point in the terms of Euclid, Einstein calls an event. But if words have any meaning, a point and an event are two totally different things. For a point is a mark, a spot, or a place, and is only concerned in the consideration of material things, while an event is an occurrence. It is something that happens. There is as much difference between them as there is between the sentence, "This is a barrel of apples," and "These apples came from New Zealand." While claiming time as a fourth dimension, Einstein explains that by dimension we must understand merely one of four independent quantities which locate an event in space. This is to imply that the other three dimensions which are in common use are independent quantities, which is not the case, for length, breadth, and thickness are essentially found in combination. They coexist in each and every physical thing, so that they are related, hence they are not independent quantities. On the contrary, time is an independent quantity. It is independent of any one or all three proportions of material things. It is not in any way related, and therefore cannot be used as a fourth dimension. We know that an event is an occurrence, and we find that what Einstein really means by his fourth dimension is merely the time by which we locate something that happened in space, and that is just what time has always meant, the period between one event and another. Length, breadth, and thickness are proportions of each and every finite thing, while time is infinite. The dimensions are finite, while time is abstract. Strangely enough, while Einstein claims that everything is in motion and nothing is stable, he allows one thing, and one thing only, to remain outside the realm of relativity, independent of everything else, and that is what he calls his second law, the Einstein law of the constancy of the velocity of light. He claims that the velocity of light is constant under all circumstances and is therefore absolute. This is a blunder of the first magnitude, but I do not imagine that he fell into it through any oversight, for it is quite evident that he was driven into his false position. He was compelled to say that the velocity of light is constant because, if he did not, his new geometry would be useless, for, after all, his geometry amounts to this. He begins by assuming that light is a material thing, so that it is affected by the gravitational attraction of any celestial bodies it has to pass on its way to the earth, which causes it to deviate from its appointed course, so that it comes to us with more or less curvature according to its distance and according to the bodies it encounters in its passage. But it always travels at the same velocity, and so if we can estimate, for example, how much the light of Canopus is made to curve by the gravitation of other bodies betwixt it and the earth, which would be done by Kepler's and Newton's laws, we can thus calculate how much longer its journey is made by those windings, twists, and turns. Then we can time its arrival because, although it has to travel so much further than its distance would be in a straight line, it always travels at the same 671,090,400 miles an hour, or 186,414 miles every second. It is true that Einstein uses a number of signs and symbols which are supposed to simplify the process, though it is profitable that they do no more than merely make it more mysterious. But the plain English of it is as I have shown, and so we perceive that Einstein uses time pretty much in the same way as we do, and not as a dimension at all. Thus, we have discovered that the things which he rechristened as an event, a fourth dimension, and a new geometry, are false to the titles he has given them. The words, as he uses them, are misnomers, therefore we dismiss them, for they are no longer of any use or of any interest to us. Now, we are free to deal with his law of the constancy of the velocity of light. We are told that light is this material thing, and that a beam of light is deflected from a straight line by the gravitation of any and every thing that lies near its course, as it passes within their sphere of influence. And we are further assured that light always maintains a uniform speed of 186,414 miles per second. We have, however, to remind Professor Einstein that the velocity of light, 186,414 miles a second, was determined as the result of experiments by the physicists Fizeau, Foucault, Cornu, Michelson, and Newcomb, all of which experiments were conducted within the Earth's atmosphere on terra firma, the last between Fort Myer and at the Washington Monument. In all these experiments, a ray of light was reflected between two mirrors several miles apart, so that it had to pass to and fro always through the atmosphere, and it is not supposed to be that light or anything else can travel at the same speed through the air as it would through the vacuum Einstein supposes space to be. Let us reverse this in order to realize it better. It is not to be supposed that any material thing travels at no greater speed through a vacuum than it does through air, which has a certain amount of density or opacity. If anything does not distinguish the difference between air and a vacuum, then it is not a material thing. It cannot be matter. On the other hand, anything that is matter must, of necessity, make such a distinction, and in that case its velocity cannot be constant. Again, if a ray of light can deviate from its course by the gravitational pull of the sun or of any other celestial body it has to pass, it must accelerate its speed while approaching that body, and slacken it again in reverse ratio after it has passed. Hence, it follows that its velocity is not constant. Once more, if a ray of light can bend by its own weight or by the law of gravitation, it is subject to other conditions, and therefore is not absolute. The length of the course used by Newcomb in the final determination of the velocity of light was 7.44242 kilometers return course. If the ray of light had deviated by a hair's breadth from an absolutely straight line, it never could have passed through the interstices between the very fine teeth of his revolving wheel, or returned precisely to the appointed spot on his sending and receiving mirrors, which were 3.72121 kilometers, or more than 2¼ miles apart in a beeline. The fact that the ray of light did pass from mirror to mirror and through the wheel proves that it maintained a straight line. Hence, it is certain that it was not deflected from its course by the gravitation of the earth between the two mirrors. Wherefore, it is obvious that it was not affected by gravitation. So we find that the very experiments by which the accepted 186,414 miles per second as the velocity of light was measured, experiments which were carried out with the utmost painstaking and minute attention to detail, prove that a ray of light is not influenced by the gravitation of the earth, even in the slightest degree. Therefore, if those experiments were good enough to warrant all the world in accepting the velocity of light, they may be equally well adduced as proof that a ray of light does not bend by its own weight, and that light is not affected by gravitation. And if it is not influenced by gravitation, a ray of light cannot be deflected from its course by anything it has to pass, so that its course remains true to the direction in which it was discharged, and that is a straight line in every direction from the source. Lord Kelvin tells us that, quote, light diverges from a luminous center in all directions, end quote. In brief, we find that light is not a material thing, that it is not subject to gravitation, that it has no weight and does not bend, and that it does not describe any kind of curve, but that it is an expression, in the same sense as sound is an expression, and that as such its velocity varies according to the density of the medium through which it passes, and that therefore the velocity of light is not constant, and Einstein's second law is entirely wrong. The question of the ether versus empty space remains unaffected by his theories, and the stars that glitter like veritable diamonds in the sky are exactly where they appear to be. So much for Einstein's second law. Now let us examine the other, the first law, or as he calls it, the Principle of Relativity, which states, quote, that all inertial systems, that is, all systems which move with uniform and rectilinear velocity with respect to each other, are equivalent in expressing the laws of natural phenomenon, end quote. That is what the law is stated to mean. It may not appear very inviting to the general reader, but he will find it quite interesting as we proceed, though it is, of course, of very great importance to every student of general science and mechanics. As a matter of fact, it is not a law at all. It is a statement. At the same time, it is not a plain statement, for it is equivocal and means something which it does not say. It is a statement by implication. It is as though we were to say, "Hello, Jones, how long have you been out of Gaul?" That would make it necessary for Jones to prove that he had not been in Gaul in order to dispose of the implication. And so it is with this statement of the principles of relativity. It is an implication. Taken literally, it is true, for it states what is already known, but it implies the reverse of what it states, that all systems which do not move with uniform and rectilinear velocity with respect to each other are not equivalent in expressing the laws of natural phenomenon. And that is very much more important. Now, if we carry this innuendo to its logical conclusion and put it into simple language, it means, quote, that no reliance can be placed upon any deductions which are obtained by means of observations to the heavenly bodies, because they are taken from the surface of the earth, and the observer is moving at a different speed than the object under observation, end quote. There would be a certain amount of truth in that if the earth was really moving, though, even if that were so, the effects of relative movement could be easily overcome by taking two observations simultaneously from opposite sides of the meridian to which the object was vertical. The effects of time would be eliminated in that way, and a mean would be found by comparing the two opposite observations. And so we find that neither the statement or law or its implication have any value. The statement might just as well have never been made. With mental agility worthy of a better cause, Einstein leads from his mechanical principle of relativity up to the special principle of relativity by means of one of the most extraordinary arguments it is possible to imagine. But, strange as it is, and inconsequential as it may seem, this argument really affects everything that comes within the range covered by the word relativity, and for that reason we will not allow it to pass unnoticed. After admitting that electromagnetic laws do not alter according to the system in which they occur, that is to say, after admitting that electromagnetic laws act the same all over the world, he proceeds to argue precisely the contrary, by saying quite definitely that in reality they do alter, and offers to prove it by the following statement. Quote, "The motion of each locality on the earth is constantly changing from hour to hour, but no corresponding changes occur in electromagnetic action." End quote. Of course, this has all the appearance of a man flatly contradicting himself, and it might even appear to be nonsense, but in reality it is a very pretty argument of the most elusive kind which is a pleasure to meet. I will confess that I admire Einstein. He skims so close round the edge of the ice. What he suggests is this. The observer is located on the surface of an earth which is rotating on its axis, and at the same time traveling through space at many thousands of miles an hour. Consequently, his place or locality is continually changing with respect to an imaginary point fixed in space. Notwithstanding this change of place, electromagnetic laws appear to act precisely as they would if this place was not changing its position with respect to that point. Therefore, Einstein argues that electromagnetic currents must, in reality, vary their speed and so adapt themselves to the changing conditions in such manner as to, quote, "seem the same to the observer as if he had not changed his position." End quote. Unfortunately, he is unable to show any reason why the electromagnetic action should do this remarkable thing, for he treats it as a thing that had intelligence, as if it willfully acted in a manner calculated to deceive the observer. When reduced to its essence, this argument proves to be no more logical than the idea that the street might be moving while the wagon was at rest. Einstein has been betrayed into supposing a thing that is altogether impossible. For example, that a physical law can act in an unnatural manner, and yet produce an effect which appears to be normal, because he began by assuming that the locality of the observer was changing, and that assumption was untrue. Now, if he can realize the fact that the earth is actually at rest, he will find that his difficulties all disappear, and that electromagnetic laws do not alter, neither does the locality of the observer change. But as Einstein persisted in shutting his eyes to the fact that the earth is stationary, he did not see the incongruity of his assumptions concerning the electromagnetic action, so that, in order to support his contention, he was led still further into error and compelled to repudiate two of the laws of dynamics, viz. 1. Quote, "Lengths of rigid bodies are unaffected by motion of the frame of reference," and 2. "Measured times are likewise unaffected." End quote. He says that these two laws of dynamics are untrue, and thought to prove they were wrong by the foregoing argument. So it becomes necessary for us to prove the fallacy of that argument in such a manner as to leave no doubt whatever as to what is true and what is false, the two so-called laws of dynamics, 1 and 2, being the stake at issue. Einstein believes that the Earth is rotating on its axis in the direction of the arrow in diagram 28, at the rate of 1,000 miles an hour, and that at the same time is traveling en masse in the same general direction along its orbit at 66,000 miles an hour. Therefore, he thinks that an electromagnetic current must travel from B to A in less time than it will take in traveling from A to B, because B is all the while running away from A, while A is always going towards B. Therefore, it appears that the measured length of a current passing from B to A, and also the time it takes, will be shorter than the measured length and time of a current passing in the opposite direction from A to B. Hence, his contention that lengths of bodies and measured times must both be affected by the motion of the observer. Of course, we know that his premises were wrong, and that A and B are both located on an Earth which is at rest, but for the purpose of the argument, we will waive that and assume the Copernican astronomy to be true. Then his argument is not so unreasonable as it seemed. Indeed, it almost has the appearance of being true. But Einstein has forgotten that the observers at A and B are both on the same Earth, that they both use the same Greenwich Mean Time, and that the electromagnetic wave passes from one place to the other by convection, so that the Earth's atmosphere offers the same facility to its passage from A to B as it does from B to A. And that is the trifle that turns the scale against him. The fact that the whole operation takes place within the terrestrial atmosphere gives equal conditions to an electromagnetic current passing in any direction within that atmosphere, the same being unaffected by anything that may or may not take place in ethereal space, which the Earth and its atmosphere in its entirety is unconscious of. Thus, an electromagnetic wave passes from A to B in the same time as it passes from B to A, just as a train traveling at a uniform speed of 60 miles an hour goes from Bristol to London in the same time as it will go from London to Bristol, while the length of the railway track measures the same from Bristol to London as it does from London to Bristol. And so, the laws of dynamics 1 and 2 remain true, while Einstein's contention has been proven false. The whole hypothesis of relativity has failed, both in the mass and in detail, under our examination, so that, unable to support itself, it can no longer aspire to support any theory of the universe. Therefore, our judgment remains unaltered. Copernican astronomy stands condemned, and has lost its last and perhaps its ablest living advocate. Chapter 14. Einstein's Evidence. It will be remembered that he offered 3 crucial tests as evidence in support of his theories, and these we still have to examine. They are, 1. That certain irregularities in the movements of the planet Mercury would be accounted for by Einstein's geometry. 2. That because light has weight, it would bend by gravitation as it passed near another body on its way to the Earth, and that this could be verified by observations taken at the time of a solar eclipse. And 3. That certain lines in the spectrum would be found to shift. We have done with mental athletics, and here we have something a little more tangible to deal with. Of the third, it is said by the authorities of astronomy that the observations necessary to prove or disprove such a shifting of the lines in the spectrum would be so extremely difficult that it is practically impossible ever to do it, and therefore it is set aside. The first is very well handled in an article by T. F. Gaynor in the London Daily Express of June 6, 1921. Mr. Gaynor meets Einstein on his own ground as a good astronomer should, and uses figures which take my breath away, but nevertheless I will leave him to deal with the crucial test number 1. He says that the discovery of Neptune 75 years ago by means of Newton's law utterly extinguishes the Einstein theory so far as Mercury is concerned. Irregularities similar to those of Mercury had been observed in the movements of Uranus, and in 1841 it was thought that these unaccountable movements must be due to the gravitation of some other planet at that time still undiscovered. But I will quote Mr. Gaynor verbatim. Quote, "Uranus is 1.8 trillion miles from the Sun. Adams and Leverrier, applying Newton's law, which according to Einstein is an exploded theory, located the probable position of the undiscovered planet 1,000 million miles still further on in space. And there Dr. Gall, the Berlin astronomer, found it, on September 23, 1846. Thus, 75 years ago, at the time of the writing of this book, the Newtonian law found a previously unknown planet, Neptune, at a distance of 2,800 millions of miles from the Sun, yet Einstein would have us believe that the same law does not hold good with regard to Mercury, which is only 36 million miles from the Sun. The so-called proof he adduces from the aberration of the orbit of Mercury can be disposed of in a sentence. he has made the elementary blunder of regarding Mercury as globular instead of spheroidal. Light and gravity. There remains now but one last defense of the theory of relativity, and that is the statement that light is really matter and that it is subject to gravitation. Test number 2. In order to put this to the test, expeditions of British astronomers were sent out to Sobral in North Brazil and to the island of Principe in the west coast of Africa to observe the total eclipse of the sun on May 29, 1919, and the results they obtained seemed to justify Einstein's main test, so that, as a consequence, the Royal Astronomical Society held a remarkable meeting at the Burlington House on November 6, 1919, and on the next day, all the world of astronomy did homage to Einstein. The result of the eclipse appeared to satisfy the gathering at Burlington House. Sir Frank Dyson, the Astronomer Royal, described the work of the expeditions and convinced the meeting that the results were definite and conclusive. Dr. Crommelin explained that the purpose of the expeditions was to test whether the light of the stars that are nearly in line with the sun is bent by its attraction, and if so, whether the amount of bending is that indicated by the Newtonian law of gravitation, viz. 7/8 of a second at the sun's limb, or the amount indicated by the new Einstein theory, which postulates a bending twice as great. The result of the observations were 2.08 and 1.94 seconds respectively. The combined result was 1.98 seconds with a probable error of about 6%. This was a strong confirmation of Einstein's theory, which gave a shift of 1.75 seconds. The fourth dimension was discussed, and it appeared that Euclidean straight lines could not exist in Einstein's space. All lines were curved, and if they traveled far enough, they would regain the starting point. Mr. De Sitter had attempted to find the radius of space. He gave reasons for putting it at about 1 billion times the distance of the Earth to the Sun, or about 16 million light years. This was 80 times the distance assigned by Dr. Shapley to the most distant stellar cluster known. The fourth dimension had been the subject of vague speculation for a long time, but they seemed at last to have been brought face to face with even the president of the Royal Society in stating that they had just listened to, quote, one of the most momentous, if not the most momentous, pronouncements of human thought, end quote. He confessed that no one had yet succeeded in stating in clear language what the theory of Einstein really was. But he was confident that, quote, the Einstein theory must now be reckoned with, and that our conceptions of the fabric of the universe must be fundamentally altered, end quote. Subsequently, speakers joined in congratulating the observers and agreed in accepting their results. More than one, however, including Professor Newell of Cambridge, hesitated as to the full extent of the inferences that had been drawn, and suggested that the phenomenon might be due to an unknown solar atmosphere further in its extent than had been supposed, and with unknown properties. With such a reception as this, it is not surprising that the followers of Copernicus everywhere should be almost willing to believe in relativity, whether they understood it or not. But the Royal Astronomical Society might have been a great deal more careful than they were, as we shall see. That the Einstein theories were automatically coming to be regarded as accepted science is evidenced by the fact that the Astronomer Royal himself introduced them into a public lecture on eclipses, which he gave at Old Vic in the February of 1921. Coming to the description of the eclipse of May 29th, a slide was shown upon the screen to illustrate the result of that observation, and were said to verify Einstein's theory. Figure 29. The lecturer described how certain stars which were in the same direction as the sun could, of course, not be seen in the ordinary way in the daytime, but when the sun was obscured, as at the time of a total eclipse, they could be seen through a smoked glass or telescope. The exact position of these stars was known to astronomy, but if Einstein's theory was correct, the light coming from them to the observer would be bent as it passed near the sun, so that they would not appear to be in their true positions. Then he showed how the Einstein theory was verified, for the stars were observed to be little further from the sun than their theoretical or true positions. But the law of gravitation is that mutual action between masses of matter, by virtue of which every such mass tends toward every other, etc., etc. Observe that it tends toward, it attracts, it pulls. Therefore, if light was matter and was affected by the gravitation of the sun, the stars would be seen nearer to the sun, and not as stated by the lecturer and illustrated on the slide. In diagram 29, the crosses XX suggest the normal true or theoretical positions of the stars with respect to the sun. If Einstein's theories had been right, the stars would be seen nearer to the sun than the crosses, but the astronomer royal demonstrated the fact that they were actually further away. Such was the real result of the solar eclipse of May 29, 1919. The circumstances had been laid before the Royal Astronomical Society in Burlington House on November 6, and yet, for some unaccountable reason, they failed to perceive that the result was contrary to the law of gravitation, and clearly demonstrated the fact that Einstein's theory is false. The real cause of the displacement of these stars from their true positions is known to the author, and will be explained in a book sequel to this work, but he does not consider that explanation necessary to the present discussion. Einstein's theory is thus disproved, alternative or no. Chapter 15. Marvels of Astronomy. Nothing now remains of that astronomy which was once said to be the most perfect of the sciences, and imagination, stretched even to its uttermost, has failed to support it in the face of reason, and yet these last 2 years since relativity became the vogue have produced the most remarkable figures astronomy has ever known. Betelgeuse. In December 1920, Professor Michelson related how he had perfected an instrument known as an interference refractometer, and how he had used it to measure the angular diameter of the star Betelgeuse in the belt of Orion, and found it to be 0.046 seconds of an arc. That is to say, that he found the measurement of this star as it appears to the eye, which is only like a glittering pinpoint, to be 0.046 degrees from one side to the other, and that is 1/20th part of a second of an arc, or 1/72,000th part of a degree. A very fine measurement indeed. Professor Michelson, however, is a physicist specially interested with theories of light, and so, having invented the instrument and measured the apparent diameter of the star, his work was done. Astronomers then took up the matter, and, on referring to their records, found the distance of Betelgeuse to be 180 light years, that is, 180 times 6 trillion miles, or 180,080 billions of miles from the Earth. And so they calculated that if a thing so far away appeared to be 1/72,000th of part of a degree in diameter, its real diameter must be 260 million miles. Then the world of astronomy pointed with pride to the mighty star that was 260 million miles from one side to the other, and told how the sun was 1,000,000 times bigger than the Earth, while Betelgeuse was 27 million times bigger than the sun. The actual size of Betelgeuse, however, depends upon its distance, and as we have shown in the chapter on 61 Cygni, that the astronomer's method of measuring stellar distance is, well, absolutely useless. We know that they are entirely wrong in supposing Betelgeuse to be 1080 billions or any other number of billions of miles from the Earth. Therefore, it follows that, as they do not know its distance, they may not use its apparent diameter and divide that into unknown billions of miles. Being in reality quite ignorant of the distance of Betelgeuse, they have no legitimate means of forming any conception of its dimensions at all. Those dimensions are to be ascertained by first finding the star's actual distance, which is something less than 20,000 miles. Then that may be divided by Professor Michelson's 0.046 degrees, which will show the actual size of that twinkling little point of light known as Betelgeuse to be not much more than 25 feet. It has since transpired that the distance to Betelgeuse had been measured on 3 different occasions, each time with a different result. One of those showed it to be 654 billions, another made it 900 billions, while others gave it as 180 light years, or 1,080 billions of miles away. And it is surprising that astronomers did not realize the fact, which was clearly demonstrated by these differences, that their methods of measuring stellar distance are not to be relied upon. In the meantime, we can see no reason why they preferred to use the greatest of the 3 various estimates of the star's distance in conjunction with Michelson's angular diameter rather than the least, for that only seems to have had the effect of magnifying the dimensions of Betelgeuse to the uttermost. Pons-Winnicke. While the excitement over Betelgeuse was at its height, the universe loomed even larger than before, for Canopus and Rigel were then said to be 460 light years away, and they may be 1,000 or more. Meanwhile, Dr. Crommelin gave us a scare with the story of how a comet called Pons-Winnicke was rushing towards the Earth at 100,000 miles an hour, while Dr. Schleifer discovered a nebulous mass that was gyrating around the firmament at 1,100 miles per second. This, so far, has never been surpassed, and Spiral Nebula number 584 still holds the record of being the fastest thing in creation, its velocity being so great that it could go from Liverpool to New York in 2 ticks of the clock. Pons-Winnicke had been somewhere in Africa in January 1921, and it was predicted that this comet would be visible at London in June, and this gave rise to much speculation. It was said that Pons-Winnicke might strike the Earth with a fearful bump about the 26th of June, but Mr. E. W. Maunder said that though there might be a bump, it is only a fog of gas after all, while Dr. Crommelin thought the comet might miss the Earth this time, and so there appeared to be no danger. Then Sir Richard Gregory said that if the head of Pons-Winnicke did hit the Earth, it might set the world on fire, but we were reassured again when he told us that there is about as much chance of the comet hitting the Earth as of a random shot hitting a bird in full flight. Yet it seems strange that he should imagine a comet to be like a random shot in this well-ordered universe, unless perchance he had forgotten about the law of gravitation. And how are we to understand how the Earth could be set on fire when he tells us that we may pass through the tail of a comet without harm, because it is really a far higher vacuum than anything that can be produced in our laboratories? Then, what are we to think of it all when Professor Fowler tells us that we don't know how a comet is formed, we don't know where it comes from, and we don't seem to really know what it is? He thought they may come from gases thrown off from the sun which are gradually cooled, but that made it even more difficult to understand how it could set the Earth on fire, or what all the bother was about. Nevertheless, the discussion continued until at last the leading authorities advanced the fascinating theory that Pons-Winnicke may have come from a distance in space so great that it is impossible to think or speak of that distance in terms of miles. That took our breath away, for it appeared that the comet might come out of illimitable space to wander amid the stars as its own sweet will, regardless of the laws of dynamics and gravitation. Even yet, the romance is not complete, for after waiting in great expectation for several months, the secretary of the Royal Astronomical Society told us that Pons had been seen again, this time with only a stump of its original tail, though even this stump was 500 million miles long and seemed to be comprised mostly of gas and meteors. It is not recorded how he knew the length of its tail, and nothing was said as to what had become of the remainder, but, to cut a long tale short, the summer came and passed, but Pons-Winnicke never arrived. He was lost, and even now he may be wandering on and on, somewhere in a fathomless space, no one knows whither, and nobody cares. The ruddy planet. At about the same time, there was much ado about the planet Mars. It had long been supposed that this planet was very much like the Earth, but inhabited by a race of giants probably about 15 feet in height. Some straight lines which had been observed on the planet were thought to be irrigation canals made by men, and one could imagine fields of cabbages, cauliflowers, and spring onions growing along the banks. Indeed, one could imagine anything. And so, when wireless operators in various parts of the world began to hear strange noises which they could not account for about the time of Ponswinnicky, the rumor spread abroad that they might be wireless signals from Mars. It was not suggested that the Martians might be sending these signals in reply to those we had thought of flashing to them in 1910, but it was supposed that the people on Mars might have been hearing things and thought our wireless operators were tic-tacking to them. So the possibility of sending messages to the ruddy planet were by wireless telegraphy came to be discussed almost as much as the comet. Astronomers said that although the Earth is about 17 million years old, Mars is very much older. Therefore, it was presumed that the Martians would probably be more advanced in knowledge than we are, and might have been using wireless for goodness knows how long, and had now discovered that we had a Marconi system. The tappings and cracklings that were heard sometimes at night were rather uncanny and could not be understood, but this was not because the Martians' language was different than ours. It was because the vibrations that affected the wireless courers were really caused by the splitting of the ice round the pole. Spring was advancing in the northern hemisphere, and the ice fields were melting and breaking before the warmth of the advancing sun, so that the colliding and shifting of huge bergs disturbed the normal distribution of the magnetic currents from the North Pole. Professor Pickering might have made this discovery if he had the time to think of it, but at that period he was busy studying the weather of Mars. I don't think he knows any more about the weather on Earth than the meteorological office, but I recollect that he told us it was snowing on the little old planet, and that was a very remarkable thing, if it was true. Indeed, it was remarkable whether it was true or not. The time was when it was said that a water ran uphill instead of down on Mars, and in the year AD 1910, all sorts of schemes were proposed for signaling to the planet by means of bonfires and searchlights at night, or by using mirrors to reflect the sun's rays by day. It was all very interesting in its way, but very nonsensical, because the sun is always shining on that side of Mars, which is presented to us whether it is day or night on our side of the Earth. And so it would be impossible for the Martians, if there were any, to see our bonfires or mirrors, because with them it must always be daylight, and they could not even see the Earth itself. This is because Mars goes round the sun on a greater orbit than the Earth, while we travel on the inner circle according to the heliocentric theory, as shown in diagram 30. It is surprising that astronomers had not thought of this, but they will find that is so, if they will only study their own astronomy. But the time has come when all the romantic things that have been said about Mars must take their proper place among fairy tales, for if the distance to that planet is measured by 2 simultaneous observations, as I have advised for the measurement of the sun, it will be found to be never more than 15,000 miles from the observer, and too small altogether to be inhabited, too small even for Robinson Crusoe and his man Friday. NGC 7006. Before bringing this history of the evolution of modern astronomy to a close, I have yet to mention the constellation of Hercules, which Dr. Shapley at Mount Vernon recently estimated to be about 36,000 light-years distant, or 200 times further off than Betelgeuse. While we are now told that is a star known as NGC 7006, which is one of those myriad twinkling little lights in the Milky Way, has been found to be about 200,000 light-years distant, and this surely is the limit of even an astronomer's imagination, for it means that it is so far off that it would take an electric current traveling at the rate of 186,000 miles every second 200,000 years to go from the Earth to the Milky Way. In conclusion, I quote the following from an article which was published in London as recently as April 15, 1922. Quote, "By other methods, most bodies in the heavens have been measured, and even weighed, and the results obtained stagger imagination. One of such methods consists in watching an object through the spectroscope and making calculations from the shifting of lines in the spectrum. In this way, the mighty flames which leap from the surface of the sun have been measured. Some years ago, one flame was observed to shoot out with a velocity of at least 50 miles a second, and to attain a height of 350,000 miles. The stars in general cannot be measured, but the thing has been done in some cases, notably by Bessel, who, after 3 years' observations of 61 Cygni, announced its approximate distance from the Earth as not more than 60 billion miles. Yet, this is one of our nearest neighbors among the distant suns. It is so close to us, comparatively, that we have learned a lot about it since Bessel made his calculations. Scientists have shown that a difference of a mere 20 billion miles in distance from the Earth is negligible, and that, though it is tearing through space at 30 miles per second, it would require about 40,000 years to make a journey equal to its distance from the sun." End quote. It is difficult to tell whether the journal was joking or not. It appears to be so, but nevertheless the statements are those given out in all seriousness in the name of astronomy. They are things which are being taught in colleges and schools as scientific knowledge in this month of May 1922, for which astronomers, the educational authorities, and the indifference of parents are responsible. However, it is to be observed that, with the single exception of Alpha Centauri, since Bessel estimated the distance of the first star to be 63 billion miles away, stellar distances have grown greater and greater, until at last we have this, NGC 7006, said to be 20,000 times further than 61 Cygni, 1,200,000 billions of miles from this Earth of ours. And this preposterous figure is the outward and visible sign of the nature of the science that has been evolved in 20 centuries through the failure of astronomers to perceive the error of Hipparchus. Adieu. The blocks used to illustrate this work were made by Messrs. W.E. Briggs & Co., Tudor House, Chichester Rents, Chancery Lane, London, WC2, while the copy was most admirably typed from the original MSS by Miss E. Barry at Messrs. Puckey & Co., 153 Fleet Street, EC4.